So we already have this basic idea that thermodynamics does not deal with each particle. Rather, we deal with a macroscopic picture. So thermodynamics describes a system using few macroscopic variables, and those are your state variables. Okay guys, so these variables are your state variables, and the state variables are related to each other, and that relationship is given a name. That relationship is also given a name, that is equation of state. Okay guys, so we have thermodynamics. Well, actually, let me write it and explain it off. So we know that thermodynamics does not deal with microscopic, but rather it gives a macroscopic view. So when we're dealing with macroscopic, we are dealing with pressure, volume, temperature, and so on and so forth. That helps us talk about it. And this is your state variable. So the equation relating all of them, has a special name, and that is your equation of state. See, there are many equation of state. There are many. But we are dealing only with one over here. There are many equations. But here, you need to know that we are just dealing with one. And also that there are many of it. And which one are we dealing with? We are dealing with ideal gas. We are taking up ideal gas and looking at the relationship. And that relationship is PV is equal to nRT. See, point of this, this thing is that we'll fix. So this is a constant, right? And basically there are three variables over here as per this equation. So what we do is we fix one, okay, and study the other two. And so we'll get to understand the system. So from here, we'll get to understand the system. Remember, we are trying to understand. See, basically it goes back to understanding how does the engine work, right? So engine gets influenced by pressure, volume, temperature, and so on and so forth. So that's one of the ways of studying an engine. Okay, so mathematically and in terms of equation, we use all of this to study an engine. Now, systematically, we have to study the engine, because if you get started with the very random nature of how things vary inside a piston, it won't be easy for us to deal with. And that's why we started with something called as quasi-static processes. That is very slow processes. And then we are talking about ideal gas now. And then we are talking about state variables. And then we are talking about the equation for an ideal gas with the state variables, making use of the state variables. That's where we are at. So next step is, when we have all of this, what is that we do? What do we do actually with all of this? So I gave you all of this information. What do you do? So if you want to study something, you have to fix one and study the other two, and thus understand the system. Okay. So that's the point of this, right? So we are making use of this. Using this equation, we end up with this. We are able to understand the system this way. So that's the entire funda over here. I think I covered up all the points of this particular set of slides. So let's have a look. We are looking at thermodynamic state variable and ideal gas equation. A system in thermodynamic equilibrium is completely described by a few macroscopic variables called state variables. And that includes your pressure, volume, temperature, mole, and internal energy. It's important for us to understand that they are not independent. They have certain relationship, and that is given by your equation of state. Equation of state is a mathematical relationship between the state variables P, V, T, and N of a system in thermodynamic equilibrium. That condition is important. So it's valid only in the equilibrium. Each substance has its own equation. Real substance have complex equation, while ideal gas have a very simple equation. Okay, guys. So what is the purpose of this equation? It will help us to predict the behavior of a system. Basically, we are trying to understand it. And once you understand it, you can predict it. So once you can predict it, you can build a vehicle or something useful out of it. That's the entire cycle of anything that we do. So that goes back to the basic idea of what is civilization, when do you tell the civilization gets started, so when does it end, so on and so forth, right? Culture, and basically it goes back to the philosophical aspect of things, right? End of it, it's all about understanding and making use of it, right? That's the funda over here. Now ideal gas equation looks like this, where we have pressure, volume, number of moles are constant, and absolute temperature. Alternatively, you know that number of moles from your chemistry class, you know that N can be written also as mass by molar mass. Okay. And PV is equal to nRT, we'll be deriving in the next chapter with something called as Boyle's, Charles, and Avogadro's law. Okay, guys. So, implication. What is the point of this? What do you learn from this? What we do is we fix one quantity, we change the other two, and see how they influence each other. That's the whole point. Right? And this is a summary. Okay. So I think, yeah, you guys, this is a good summary, to be honest. If you guys want to write this, you can write this. And then you guys can see if you want to write something from this.